in this lecture we study about Lewis structures, and we see how to draw Lewis structures given a molecular formula. Lewis structures are like 2D structures of a molecule, and if you're given a molecular formula, how do you derive the Lewis structure? Well, first of all, you try to identify the atom in your formula which has the lowest electronegativity. And the atom with the lowest electronegativity, that is what you usually assign as the center atom. And then the other atoms with higher electronegativities, these are the atoms that you put at the surroundings or the periphery of your central atom. And by doing so, you are able to form the atom placement or your atom network with the atom with the lowest electronegativity at the center. So once you have the atom framework or the atom network, the next thing you do is you try to get the valence electrons of all the atoms in your molecular formula, and then you add them together. The number of valence electrons of an atom, you can usually get this by obtaining the A group number of your atom. The A group number of your atom, you can get this from your periodic table. Like for instance, for fluorine, the A group number would be 7. For nitrogen, that would be 5, and it corresponds to the numbers in the periodic table. Then once you add all the valence electrons, then you have the sum of the valence electrons, and then the next thing you do is, given your atom network, you connect the central atom to each of the peripheral atoms. And then once you connect all of the atoms, the peripheral atoms to the center atoms, for each bond that you put, you have to subtract 2 electrons from the sum of the valence electrons. And then once you subtract the bonds from the sum of the valence electrons, remember 2 electrons subtracted for each bond placed. The next thing you do is the remaining electrons, you distribute them to the rest of the atoms, such that all of the atoms, or most of them, would have an octet set of electrons. So you can distribute the remaining electrons as lone pairs, or if not lone pairs, you can distribute them as double bonds or additional bonds or triple bonds. But the end should be ideally every atom, whether the central atom or the peripheral atoms, most of them should have an octet, meaning most of them should have 8 electrons surrounding them. So each atom should have more or less 8 electrons, and when you do that, you have the Lewis structure. So let's take a look at, for an example, for nitrogen trifluoride. First, you try to write the atoms in space here. Nitrogen has the least electronegativity, so that's what you put in the center. And then the fluorine with higher electronegativity, you distribute them around the periphery of your nitrogen. Then the next thing you do is you account for the valence electrons. So nitrogen has 5 valence electrons. You can get that from the periodic table. Your fluorine each atom of fluorine has 7 valence electrons, and you have 3 fluorine atoms, so that gives you 21 electrons. And if you add the total number of electrons, that would give you a sum of 26 electrons. Then the next thing you do is you connect the peripheral atoms to the central atoms, so you have 6 bonds there, rather 3 bonds, and the 3 bonds would correspond to 6 electrons, because each bond has 2 electrons. So if you have 26 sum electrons, you subtract 6 from that to get 20 electrons left. And the 20 electrons left, that's what you distribute to the remaining to the atoms in your molecule. Usually you first try to distribute them as lone pairs, such that you attain mostly the octet rule for each of the atoms. So for instance, you can put 1, 2, 3, 4, 5, 6. You can put 3 lone pairs for your fluorine over here, and when you put 3 lone pairs, then your fluorine would have 8 electrons surrounding it. You have 1, 2, 3, 4, 5, 6, 7, 8. The same goes with your other fluorine atoms. Now for your nitrogen, if you put a lone pair there, then your nitrogen would have 1, 2 for the lone pair electron there, and then you have 1, 2, 3, 4, 5, 6, 6 electrons due to the 3 bonds. So 6 plus 2 due to the lone pair, that would give you an 8 electrons, which fulfills the octet rule for your nitrogen. Okay. So once you distribute all of those electron pairs, then you can account it for your sum over here, and they should total up to 26. So the number of bonds, 2 for each bonds, and the number of lone pair electrons, all of them should sum up to 26. Okay, let's try to look at this example over here. Here you're given a molecular formula of CCl2F2, and you're asked to draw the Lewis structure of CCl2F2. So first, you try to identify the atom with the least electronegativity. Usually in your periodic table, as you go to the top right, then the electronegativity of the atom increases. So in this case, your carbon would have the least electronegativity, while chlorine and fluorine would have higher electronegativities. So since your carbon has the lowest electronegativity, then that's what you choose as your central atom, and that's what you put at the center over there, while the other atoms, you put them at the periphery. Then the next thing you do is you try to account for all the valence electrons. So carbon has 4 valence electrons, while your chlorine and fluorine each have 7 valence electrons. Since you have 2 chlorine atoms and 2 fluorine atoms, then you sum 4 plus 4 times 7 would give you 32 valence electrons for the whole molecule. Now, the next thing you do once you have counted for all the valence electrons is you try to connect all of the peripheral atoms to the central atom. And then for each bond that you put, for each line that you put, you subtract 2 electrons from the sum of the valence electrons. So, in this case, you have 1, 2, 3, 4. You have 4 bonds that corresponds to 8 valence electrons. So, 32 minus 8, that would leave you with 24 valence electrons that you would need to account for. And these 24 valence electrons, the first thing you can do is you can distribute them as lone pairs to the peripheral atoms, such that all of the other atoms would have an octet fulfillment. So in this case, you can put 3 lone pairs for the chlorine here, 3 lone pairs for the fluorine, and then this fluorine would have 3 lone pairs as well, and this chlorine would have 3 lone pairs. And by doing this type of lone pair distribution, you would notice that the peripheral atoms each have follow the octet rule, meaning all of them, each of them has 8 electrons. One, like for fluorine, you have 1, 2, 3, 4, 5, 6, 7, 8. And the carbon follows the octet rule as well, because each of these bonds you can count as 2 electrons. So it has 4 bonds, and then each bond has 2 electrons. So your carbon would have 8, would have an octet over there. So this structure down here would correspond to the Lewis structure, which is like a 2D representation of your molecule. Now let's take a look at this example over here. Here you have to draw the Lewis structure for methanol, and the formula for methanol is CH4O. So in this case, you actually have 2 central atoms, because your hydrogen over here can only have 1 bond. So usually your carbon can have 4 bonds, your oxygen can have 2, your nitrogen can have 3, but your hydrogen usually it can only take 1 bond. So knowing that your carbon usually has 4 bonds, your oxygen has 2 bonds, and your nitrogen has 3, then a possible arrangement would be something like this one here. Now the next thing you do is you account for all the valence electrons. You have 14 of them. and then you start connecting the atoms together, and then once you account for all the bonds, you subtract the number of electrons from the bonds from the total sum of the valence electrons, and that leaves you with 4 valence electrons, because you have 1, 2, 3, 4, 5. You have 5 bonds over here, and each bond corresponds to 2 electrons. So 5 times 2 will give you 10, and since you have a total of 14, 14 minus 10 will give you 4 valence electrons left, which you have to account for. So these 4 valence electrons that are left, you can add them as lone pairs. And for the oxygen here, since your oxygen can normally just take 2 bonds, then you can put you can add additional lone pairs to your oxygen over here, and by doing so, your oxygen would follow the octet rule. Your carbon would follow the octet rule as well. Now your hydrogen, well, it can only take one bond, so usually your hydrogen wouldn't follow the octet rule. Now let's try this other problem. Here you have ethylene, C2H4, and you have to draw the Lewis structure for this one, and also for nitrogen gas, N2, which is the most abundant atmospheric gas. So if we follow the previous steps we've been looking into in the previous slides, we'll end up with this Lewis structure for your ethylene, with single bonds everywhere, and you have a lone pair in one of the carbon atoms. But if we do this, notice that this carbon over here, it follows the octet rule, because you have 1, 2, 3, 4, 5, 6 due to the 3 bonds, and it has 1 lone pair here. But this carbon over here, it does not follow the octet rule. In fact, it just has 6 electrons, 1, 2, 3, 4, 5, 6. And so this molecule over here wouldn't be quite happy, because one carbon follows the octet rule, while the other does not follow the octet rule. So in order to fix this this problem over here, one way to do it is you can convert this lone pair over here into an additional bond that connects the 2 carbon atoms together. And when you do that, you form a double bond between the 2 carbon atoms. And by this configuration, you'll notice that each carbon now follows the octet rule, because each carbon has 4 bonds, and each bond corresponds to 2 electrons. Now for the case of nitrogen, if we follow the previous guidelines we've been looking into in the previous slides, the Lewis structure that will end up looks like this one down here at the left. But if we analyze this one, each nitrogen would have 1, 2 due to the bond, 3, 4, 5, 6 valence electrons. But ideally, your atoms would want to follow the octet rule, meaning each of them would want to have 8 electrons surrounding them. So in order to fix this problem, where the atoms do not follow the octet rule, we can promote the electrons into the lone pair electrons. We can promote them into bonds, into additional bonds connecting the nitrogen atoms together. So we can convert this for this electron over here and this electron over here to form an additional bond that connects the nitrogen atoms together. But if we do this, each nitrogen would have 1, 2, 3, 4, 5, 6, 7. Each nitrogen would have 7 electrons surrounding it, and it wouldn't still fulfill the octet rule, which these atoms would want to attain. So in order to attain the octet rule, we can promote another lone pair, or another electron over here, a nitrogen, to form an additional bond. So we can move this electron down here, and then this electron down here to form a third bond, and now you have a triple bond for your nitrogen. And when we account for the number of electrons surrounding each nitrogen atom, we have 1, 2, 3, 4, 5, 6, 7, 8. So this time each nitrogen atom has 8 electrons, and both of them fulfill the octet goal. Alright.